Welcome to Statistics, Introduction to the Normal Distribution by Martin Tutorials. I will be introducing you all to the normal curve and the normal distribution, and of course the names might vary depending where you're learning or the course. I produced a YouTube called Statistics Simplified for Beginners, which is on my other YouTube called Variety and Fun Math. You might want to watch that first, and I am putting a link into the descriptions. Okay, this is what's called a normal curve. This shows how things sometimes, not always, behave in nature. I'll just give you an example. Let's say we're scientists and we're learning about a particular type of tree. All right, and we've got thousands of these trees in this particular forest. And what we're doing is we're analyzing the height. And we know from before the average height is 10 feet for this particular tree. And what we do is we make a chart. Let's say we number it starting at 0 with 10 in the middle and then going up to about 20. And every time we measure the height of a tree, to make it simple, we'll round off the nearest integer. We put a little vertical dash. If that's 7 feet tall, we'll put a dash where the 7 is. Okay, I never wrote numbers in because it could be lots of numbers. I'm making up the numbers now. That tree is 8 feet. We'll put a dash where the 8 is because we didn't put numbers underneath. If that tree is also 8, we put another dash on top, which will increase. It'll make it a vertical line. And if we assume all these dashes are the same size or the same length, these vertical lines, we will start creating lines that represent how many of that height of trees. So, for example, where the number 11 is, the length of that line will represent the number of trees that are 11 feet high. And of course, if each little dash that we connect the same height, if the average is 10 feet, we're going to find with the length of those vertical lines, it should follow this design, this shape, from the height of those lines. Because more are close to the average, the further away from the average, the less trees there are. That's how things often, I never said always, but often work in nature. Maybe there's another type of tree out there where has some have an unusual condition that there are a few that suddenly go incredibly large. Then you might get this shape, and then at the big end that suddenly goes up again because of that. So this is the way things should go, or often go, or not always. It's same thing writing a test. If the average is 50%, more people will get 50 than any other score. The further away from 50, higher or lower than 50, the less people will get it. And of course, there's exceptions to that rule. Okay, now to demonstrate this, I made up a question. And there are some concepts in the question I haven't explained yet, but I'll explain it with a question. Joe writes a test. Thousands of the people write this test, and thousands have written it already. And the test results follow a normal distribution. Same thing, if I do a chart like this, and we fill in the scores, let's say from 0 to 100, depending if the number of people who got 40% will represent the length of the line above the 40. Okay, that's why this follows a normal distribution. The average is 79%. Joe got 84%. Now, I know I haven't explained this yet. I will explain it. We're told the standard deviation is 6. What percentage got above and below Joe? And that standard deviation refers to the variance. Remember, we said the average for this test is 79. All right? Now, whatever the variance is, it's still a normal distribution. If we have a case where that's 79 and we have 75 over here and 83 over here, nearly every person got between 75 and 83. It's still a normal shape, but everyone got close to 79. Then clearly Joe's 84 is brilliant. He did better than nearly everyone. if this range starts from a much smaller number to a much bigger number, then Joe's 84 would be much closer to that 79. So he got above average, but not that much better relative to other people. That's why to work out what percentage got above or below Joe, we need to know the spread from that 79, not just what that average is. This number 6 is a measure of that spread. The statistics term is called the standard deviation, and there is a formula which I will explain in another lesson. We don't need to know it for today. They tell us it's 6. We don't need to calculate. We could take all the scores of that test. The more students, the more accurate. We plug in the formula and we get 6. Okay, so what we do now is, what I do is I let X be Joe's score, which is 84. What I'm going to do is calculate the Z score, which I'm going to explain. Now, what would make life simpler is if I had a chart here which tells us for this test, for each score, how much above or how much below. If you get 79%, 50 above, 50 below. If you get 80%, 49 above, 51 below. If you get 82%, this much above, this much below. It'd be much easier. Just take that 84, it says 84, get this much above, that much below. I just did that chart. I don't have to do any math, but I don't have that chart. So what we do is we use, it's called a Z chart or a normal curve chart. There are lots of names of it depending on your course. This is a chart for calculating percentage, but the problem is it's not the chart for the test that Joe wrote. So what we've got to do is take his 84% that Joe achieved, good for Joe, and convert it to a corresponding number for this chart. And what I mean by corresponding number, if we told it's 20 degrees Celsius and we found the corresponding number in Fahrenheit, those numbers correspond. That number Fahrenheit's the same as this number in Celsius. Or this is 2 meters long. That's the same as saying 200 centimeters long. On the other scale, that 200 corresponds to this 2. So this 84, let's pretend 10 people got above Joe. Don't know yet, we're still solving. The Z score is the corresponding number on that chart where 10% are above. So the Z score is a corresponding number where the same number is above or below on that chart versus the numbers above or below Joe on the chart I wish I did have. Okay, and so X is Joe's score, Z is the corresponding score for that chart. And to convert, just like there's a way to convert from centimeters to meters, this is a way to convert from X, Joe's score, to Z for that chart, because we don't have the chart for this test. And it's X minus average, and the symbol for average can depend on your course, which is 84 subtract 79 divided by the standard deviation, which is 6. And the answer is 0.8333. The Z score for Joe is 0.833. 0.833 on this chart corresponds with that 84 which Joe got. Now charts can vary. There's 0.8, and then I'll go to the 3 above 0.833, and the charts can vary, and it's where my fingers is 0.2967. It's 0.8, and that 3 is the other digit. It says 0.2967, and that tells me on this chart how much above 0.5. So if he got 0.2967 above 0.5, he got 0.2967 plus 0.5 better than everyone else. Okay, and some charts tell you everything, some charts start over there, and at the moment, you don't have to worry too much about this chart because charts differ. I want you to understand that I took the Z score and looked up that proportion on a Z table. That's the whole point, because I do not have a table for that test. So look up on this table. Okay, so that 0.2967 plus 0.5 is 0.7967 when I add those two numbers together, and that means 0.7967 got below Joe, and 1 minus that gives 0.2033, which got above Joe. But if we look at the wording of the question, they said what percentage got better and what percentage did worse. So I like to answer the way they asked. So if he did better than 0.7967, that means 79.67% did worse than Joe, and 20.33 students did better than Joe. That's very good. That means a huge portion of students did worse than Joe. And what we have written there is the answer to the question. That's the introduction. I hope you enjoyed it, and talk to you all soon.